Okay, thank you very much. Sorry, I cannot enable my video because of the limitation of the bandwidth. So let me start about my presentation is on the status of the policy and the national soil information system. Before I go to the policy and the database, I would like to go through the pre-initiative of the policy and the modern information system. Before the initiatives of the two projects, that is the policy and the national information system or the modern information system for soil. As you know, these are the rationales, accurate and update data, up-to-date information about soil fertility, is critical, as you know, for developing to smart policies. And in particular, in our country, we have faced a challenge in food security and the global problem, as you know, the climate change mitigation. So because of this, we need the soil data and information in a proper and in standard way. Okay, so before the NSIS project, we have some initiatives, some data collection in the country. You can see the type of study and the objectives, the year, but this data is not properly handled or managed or stored. That's the critical problem. And as a result, for the past 5 decades, we're using blanket fertilizer application recommendation. The only nutrient supply to crops was limited to nitrogen and phosphorus. And even the depth soil fertility information was constrained. And there was no fertilizer policy and recommendation. As a result, a major initiative in 2012 was launched by the name NSIS project. Go ahead. So in the NSIS project, you can see these are the components of the NSIS projects. The first one is soil sampling gathering, and the second one, soil processing, laboratory analysis, output, and so on. Soil library. So this data collection, everything was conducted through the state-of-the-art technology, employing remote sensing satellite technology. But as a result, when we have this all data, even the output, at the end, when we reach in the information distribution, there are two questions that was raised. The first one is, how can the data be shared? This initiates the policy. The second one is the infrastructure. There was a data, but there was no proper infrastructure. So at this time, even the national information system has emerged. This was the initiative for the two. So in this NSIS, we have in our hands or at the, as a standalone server, 748 districts and 64 point survey in our hands nowadays. And you can see from this, we have 50,000 soil samples collected, and we have 80,000 soil samples are collected here for the soil fertility survey. This is for confluence point, and machine learning is applied, and this all is processed, and we have even generated different maps for different districts. So, as I have mentioned previously, due to this data, availability of data, the problem of sharing, this soil and agronomy data sharing policy was launched. I will not go through the policy one by one because it's not rectified yet, final rectified, but I will just go through the main points. The scope, the policy scope. The policy scope states that this policy includes all the soil and agronomy data, including even the pre-existing data. This is the first one. Again, the policy is applied to all, including the non-government organizations. And it's designed through the principle called FAIR, which recommends that it should be findable, accessible, interoperable, and reusable. And the policy is audited by Ministry of Agriculture on the behalf of the government. Let's go. The purpose, as you know, as everybody understands, is by implementing this policy, we can prevent duplication of effort in collecting and analyzing soil information and agronomic data. And at the same time, the policy will ensure up-to-date soil agronomy data for policymakers to make or to formulate agriculture policy recommendation. And the policy is intended, again, to deliver value to farmers. And it uses different standardizations, including some international standard data. Continue. So the policy implementation, we have the policy. At the same time, we have developed an implementation, policy implementation guide to support the policy implementation. So we have the manual at the same time. Yeah. So I think we have developed policy implementation guide to support the policy. This is line by line implementation of the policy. It details all the policy, the fair everything policy in details. But investment will be required to deliver this policy. Investment means investment in technology and in human capacity, in advocacy, and so on. The policy will be enforced for 3 years. That's the general idea of the policy. But we will not present the whole policy because it's already now, since the policy is not rectified, but we expect, since it's already in the Ministry of Management, Ministry of Agriculture Management Committee, so we expect this to be approved shortly. And at the same time, I forgot something. Every policy, and including the guideline, is translated in Amharic. This is what is the status of the policy. Let's go. So let me now go to the major presentation of mine today, the National Soil Information System. As you know, the National Soil Information System was launched before 1 year, but we were expecting this system to go live last February. We are now 6 months behind the schedule. This is due to, first of all, the COVID, of course, and at the same time, we have to accept, we have to admit sometimes, you know, there was no proper mitigation strategy. One of the champion of the NSIS has left. The core or the primary focal person for this project has left. So at that time we had some mess. So this, because of this, the go live of this database was delayed. We have to admit. The component of the database is like this, as you can see from the screen. We have the content management. The content management is the landing page. All the public information regarding the soil will be available in the content management. In the content management, all information will be public. No login, no authentication. And we have a soil collection module, and the second one is laboratory analysis. We all have their own virtual sites. For example, if for a surveyor, we have a soil collection site. For a laboratory technician, we have a laboratory site, and so on, for the output and so on. This is the whole scope. And we have at the same time soil tracking. All the soil sampled from the ground all the way to the library will be tracked, will be easily tracked. The system has tracking system and have notification. For example, if the soil is collected, then send to the laboratory. When the soil collected is approved by the surveyor head, then it will go automatically to the laboratory, and the laboratory technician or head will be notified. So it has notification and soil tracking system. Okay, so this is the login page. This is the login page. We have a landing page that just I jumped that page. The landing page is a public page, but after that we have a login page. This is an authentication. For those who are authorized, they can log in through this window. Next, for example, we have here the laboratory module. So as you may understand, we have different laboratories. So virtually we have to create laboratories here. The laboratory profile. We create all the laboratory, their location, and so on. So this is how we can create. This is a window for the laboratory. And the testing type, this is another object, very important object, because we have different test types. We have to create as one object the laboratory test types. And at the same time, we have the user management, as you know, for this is standard for all type of large scale information systems. We have a create role. We have different roles here. I have to discuss because this is very important. We don't have a predefined roles. We can customize roles. So this is one of the advantage of this system. We can create roles. We can have some privilege for someone, and so on. This is how we create roles. So after having a role, different roles, then we can create users. Of course, this is how when the users register to the system, then we can assign to the roles. They can create online, they can register to the system. Then when they are valid, when the administrator verifies whether they are valid or not, then assigns a role. Next, the other important thing is survey forms for data collection. We have an electronic survey form here, and like that of the roles, the forms are not predefined. We can create fields, we can link fields with the forms and so on. Here you can see that we are creating fields for the forms. We can here Border code and so on. You can see topography, elevation, date of sampling. This is created by anyone. It's possible. The second one is creating a form. We have created a field for the form before. Then what we can do is now we can add these fields that have been created to the forms. For example, here, soil characterization form. You can count here. There is a count here. Number of fields for this are 10. So you can add fields, you can reduce fields as you like. That's how you can customize the form. So this is, for example, the how you link the surveyor with. Here you can see how you contact the surveyor with the locations. You can see here. These are the assigned servers and the assigned surveyors and so on. Next. Then when you assign the forms to surveyors who are in the field, then the surveyors in the field will have a tablet or a mobile, they can log into the system. Of course, they have to create first. They have to be validated and so on. They have to go all to the processes. Then they can use their username here and password. They can log in. Then they will have this landing page for them. Here, fill blank forms, edit blank forms, finalize forms, and so on. You can see. Next. Here, then the same tablet, the same user. After that, they can have sample collection form. These are the forms that is sent or assigned to this particular surveyor. Then when they open this sample collection form, it's a dummy data, by the way, then this will be the fields. Scan sample plot, upload image, sample site name, upload image, here, sorry, surveyor name, soil location, and so on. So by clicking each field, they can easily, for example, for the scan, they can easily scan the bug bar number, and so on. Go ahead. You can see here. Now the device is scanning the barcode. This is for identification of that soil sample. And they can enter the surveyor name and so on. This is how they can add the fields. They can fill the forms. Go ahead. And so on. Even the location, they can take the location and upload the image. This is how they proceed. Go ahead. Then when they finalize, when they are sure, then they will say, they will click this one, go to end. If they have some mistakes of, if they want to go back, go to start. This is go to end. Then the next will be the next. Yeah, the next will be like this. These data are already finalized or completed. Then you can, here you can see, sorry, back one, okay. Then you can, these are the filled or the completed forms. Then if they want to send, because the completed forms has to go to the administrator or to the surveyor head for verification. So they have to even can select all, they can select all by this, then they can send, or they can select by one. When they send, then automatically they will have a report on their device that these forms are sent already to the administrator, of the surveyor, of course. Go ahead. So this page again is for admin, surveyor admin. So he will receive all the completed form and he can check. That means. Then when there is updates, he can update, or there is, if he wants to reset, to resend again back if there is some error and so on by the surveyor, either he can reset or he can update. If some information has to be updated by himself or by herself, he can update the data. It's possible. Okay, go ahead. Then the administrator, when the forms are completed, cleaned everything, then it will approve it. When the completed forms are approved, then it will go automatically to the laboratory as a test report. Okay? Then the laboratory will see all the sent forms. Then they can test. the testing process will start. So this is, everything is virtual. It's good. When they click approve, then it will go automatically to the laboratory. Go ahead. So, of course, for the laboratory, at the same time, they have the database, their own data management system. So when they process the results, the test result, they can either key from the keyboard here, they can put the pH and so on, the results, or if they have their own Excel version or PDF version, whatever, they can here upload. Here they can browse and upload any version. It could be PDF, Excel, and CSV, and so on. This is possible. Go ahead. So approval and rejection of lab results. This is again done in the laboratory. Here, verify. It says verified, so it's possible to approve and reject lab results in the system. Go ahead. Then finally, the library. When the test result is approved, then it will be sent to archive automatically. Then the library itself will have a module to set the location of each soil sample. You can see here rack number, shelf number, and so on, drawer, and so on. This is available in the database as one module. Okay, when it goes from the lab to the library, then automatically the archive mechanism will be done by the database system itself. That's how it's archived. Go ahead. Then the next process will be, now we have the lab result. The next will be, the important will be the output generation by using some machine learning. So here, the system uses two options. The first option is we plug in, or the system plug in the NIM by itself. The system has the NIM, but as you know, NIM is an open source, so it's not reliable. So you can here, you can automatically schedule the NIM in the system itself. Then sometimes it may be successful, as you can see here, scheduler starts complete. This is successful for this generation, that means for this field. Here again, completed. This failure, sometimes it could fail because we cannot rely, because it's an open source, as I have told you. So what we can do is the failure status, we have to download to our workstation, so process and upload the system again. Okay, that's how it's designed, because the NIM, as you know, is an open source. Go ahead. So as I have told you, upload NIM if it fails, if the scheduler fails for some cases, what we can do is upload and download. Download and upload, of course. We download from the system the result of the lab, then we process it by NIM of the system, then we upload it to the system again, the result. Go ahead. The same for scheduler, for ML, for the R script, the same. We have the scheduler at the same time for the manual option. If the scheduler fails, what we can do is we have to work it out offline and upload it, the result. Okay, next. Then the last one will be cartography, mapping. upload the image, and so on. The result, when you have the result, the ML algorithm output will be up the input for this, then maps will be generated here. Next. Then this is the process, the final output. We have the final output. How do we distribute the data? How do we distribute the information or the reports? So we have here, for example, this is one reporting mechanism. We have here soil fertility status map, soil fertilizer recommended map, soil sample collection map. We have different reporting mechanism. Go ahead. For example, here we have soil fertility. Before that, we have one more. I think you jump to. Is it next? Next, maybe. Yeah. Here you can have. Okay, let's go back anyway. Sorry. So you can see here some maps. This is, I think, a map for Tseggai. So here you can see calcium carbonate in Tseggai, how it looks like, calcium to magnesium in Tseggai, how it looks like, iron, and so on. So we have such type of reports, and we have soil fertility. This is soil fertility maps, and we have next. So you can download even. You have it's possible to download by simply clicking. Then it will be downloaded to your desktop or laptop. Next. The same. We have again soil fertilizer maps. We have different as per the data availability. We have the soil fertilizer maps. You can see here. Next. The same. Here is a detail. The detail. This is I think the regional, and this it goes up to Warada level, I think. Next. Okay. The last one is what is the status now? Where we are now, and the way forward. Currently, we are under deployment. We start deploying the system since yesterday, I can say. So after deploying the system, the next will be we will officially launch the system. Then next will be, I forget here, the next will be we will migrate all the data in ETOSys, because the format is the same. So the migration will not be very difficult. So we will migrate all the data that I have mentioned already, which is collected in the ETOSys project. Then after, our plan is to provide intensive training across the country for potential users that will, of course, the next, regarding the policies, again, after the approval of the policy, we will have an awareness program to all stakeholders and actors. And finally, and most importantly, I would like to thank ATA for the project, of course, for the development of the national sale information, and for the policy and every support. GIZ has a lot, has contributed both technical and financial support for both the project, for the national soil information in every gaps GIZ was filling, and at the same time for the policy, it had very important contribution. So I would like, on behalf of the Minister of Agriculture and personally, to thank the IZ. Thank you. Thank you.
Thank you very much, Mr. Tseggai. That was a very, very informative and interesting presentation. So sorry about that. Mr. Tseggai works in the IT department of the Ministry of Agriculture. Mr. Tseggai, can you just tell us what is your role, what has been your role in the development of the policy and the Soil Information Service? What is your position in the IT department and the work you do?
Okay. Sorry, I forget to introduce myself. My role was advisor or consultant for the development of National Soil Information System. I was a counter consultant for the international firm, which is developing the system. It's an international firm. So I'm a counter consultant advising the Ministry of Agriculture in the milestones of each process of the National Soil Information. That's my role.
Great. Thank you. Thank you so much, colleagues. There was a lot of activity in the chat box. So I'm just going to ask you, Mr. Tseggai, to address some of the questions. Some were answered by our colleagues, but just for the sake of everyone, perhaps who was not following on the chat. Could you tell us what is the expected timeline to get the policy ratified?
Shall I answer it? Okay. The policy, you know, when we have the English version of the policy, we have presented to the management. Then they need the Amharic translation. So what we did is automatically we translated it by the support of GIZ. Then we have submitted already both the versions, English and so we are waiting. So it's very difficult for me to tell you because it's under the management. The ministry has to be involved. The ministry, all the state ministries. So it's very difficult, but it is on the table of the management committee. That's the committee. That is what I can say.
Mm-hmm. Okay. There was a question here from Mr. Lema who was saying, what about other stakeholders, users, individuals, students, researchers? Is the policy only for policymakers?
No, the policy is for all actors. Students are at the same time actors. So everyone is involved because, you know, the policy is about soil collection, soil sharing, and so on. So everybody is an actor, which is in the community of soil and soil information. So the policy is for everyone working in soil environment. I don't know if it is about the database. The database has different privileges for public and for everyone, for researchers and so on. So we'll lead, of course, the policy will lead us to how we can design the privilege. That's what I can say.
Mm-hmm. Okay. Then there was questions around the lifetime of the policy and why it's restricted to 3 years. Could you explain on that?
Well, it's because it's dynamic, you know. The world is dynamic, so it's very difficult to have a fixed policy, isn't it? So it does not mean is when 3 years is finished, it does not mean that it will be completely changed, but it needs some improvement. So because of the dynamism, the dynamic nature of the soil, the science, everything, I think 3 years is enough. I don't know if Lu'ul Tseggai can help here.
Yeah.
Okay, yeah, I think I also tried to answer some of the questions, and I remember we were discussing whether to have 3 years, 5 years, or leave it open. So the suggestion from the majority of the team here is 3 years can be mentioned, but they also stated we can say this is a live document that will be updated regularly as the need arises, rather than mentioning 3 years. So maybe we can see if there is a need to revise, or we may wait these 3 years for 3 years, and then during that revision, we may remove the mentioning a number of years, so it avoids confusion. Otherwise, I think the suggestion from colleagues, including Kinde from CIMIT, is it will be better to leave it like open, but it indicates that it's dynamic. The situations globally, nationally are dynamic, and therefore there will be a regular update as the need arises. So we can mention like that. So I think what you answered is the same as I tried to say in the chat. Thanks.
Thank you, Dr. Losegan. Okay, there's some questions around the soil information system service. There's one here about the quality of the data. How is the quality of the data going to be controlled or checked? How will the system handle this?
Quality issue. The quality issue, as I have told you, is, for example, from data collection from the ground, we have 2 steps, the collector and the approval. So this is one aspect. The second one is we use state-of-the-art technology for data collection, the remote sensing, the satellite image, and so on. So this is what we have. The system has this only, but otherwise the quality is, it's 2 steps: the data collector, and at the same time the next step is the administrator will validate the data. That's how we validate the data. That's what we have currently.
Thank you. Does the soil information system have APIs for access? That was another question. Hello?
When data is being collected, the likelihood of making mistakes will be minimized because the option that quality, there are 2 ways also have suggested maybe the course we present and we'll discuss in the web portal presentation. Thanks.
My apologies, my internet just dropped. Sorry about that.
So internet in the UK also can drop?
Yes. Where are we, Dr. Losegan?
So we were answering on the data quality. Tseggai comment, I complemented a few things, but the important thing is we want suggestions, because our offer of solutions for that web portal is also not very crystal clear. If the IT person doesn't know whether a certain data has the quality that's required, what will happen? You may direct to someone to handle, to check, but who is that someone, and so on. There are some things we can clarify. If there are more questions, you can, I don't know if there are more questions. I think most of them, the key ones, you raised them, but if you think there are more, you maybe end the time, depending on the time you have.
I think we can do a few more.
Yeah.
So there was a question here about GPS coordinates. They say, will the soil data have GPS coordinates? If yes, does the system automatically recognize the coordinate systems used during data collection?
Answer is yes.
Okay, simple yes, great. There was another question here. Is the citizen dashboard for farmers or others? Since it is in English and very technical, how can it be used?
Yeah, our plan is not for farmers, rather for DA, for the development agents who are distributed throughout the country, who are helping the farmers. That's our target. It's not the farmer itself, the target. So that's why we have the English version of it.
Okay. Another question: is internet connection required to log in? If so, how will you manage if there is no internet connection, especially in remote areas?
Well, in case of data collection, we have offline version for data collection. When surveyors are in the field, when they are collecting and the data and have to get connected to the server, when there is no internet, there is an offline version. In their tablets, we load the mobile version app. Then they can stay all the data they can upload. Then automatically, when the internet is restored, then it will synchronize. There is no problem. That's for data collection. Otherwise, for the other option, we have a problem yet. We don't have any solution. For example, accessing the server when there is no internet at this stage, we don't have a solution, to be frank. Okay, but for data collection, for the other way, data collection, we have an option, an offline option. That's as a remedy.
Okay. I don't see any more questions here. Don't know if you can answer this one, but there was one asking about if anyone, either you or anyone here, Dr. Rose, can you inform or update on the current status of ESRIC?
Maybe Dr. Lul said is better.
I think Professor Shallama is the one who asked it, so I'm not sure. Professor Shallama may elaborate a bit further because I'm not sure what kind of update is required.
Yeah.
Is Rick the one which is in Europe, or I don't know, maybe Professor Shallama, when is it?
Yes. Thank you, Dr. Lusagad. I wonder whether this ISRIC is Ethiopian Soil Resource Information Center. It was supposed to establish and handle all these, and I wonder whether anybody can inform what the status is today.
Okay, ISRI, that was ISRI. Now I remember.
ISRIC, okay.
Okay, Kuflu is to update about that one. It was a very big thing that was moving fast, I think 3-4 years ago, but now there is no much action, but Kuflu may comment. Kuflu or Tseggai from the, or Taklu if you have information. Kuflu is not there. Kuflu is the one who may know. Okay, maybe so when we have updates, we will provide. So about
No
this.
problem. Thank you so much. That's enough.
Okay.
Okay. Okay. We've got Wabne here, saying, please ask why Theosis is so late for use. Why is it so late for use?
You mean Ethiosis or what?
Ethiosis. He says Ethiosis here.
Yeah.
Yeah. If you can take it, Mr. Tseggai.
As I have mentioned it, we have two important problems. When we have the data, the data is organized, everything, but we had two problems. The first one is the policy. Who is to access the data? And we need the infrastructure, proper information system. That's why we initiate the policy, the national soil and the agronomy policy, and at the same time data sharing policy, and at the same time the national information system. So then we'll start sharing the system virtually from where we are. Okay, it will be a web-based system, so everyone can access from anywhere. That is the reason.
Great. Okay. Well, I think we can.
There's one question from Professor Muthuku. I don't know if you have raised it. So it says, maybe Tseggai will comment. Who will be the owner of the database? So I think the database that is presented now is under the ownership of the Ministry of Agriculture.
Yeah,
there is a follow-up question. It says, will this be acted by law? I don't know. Tseggai, do you have comment or you want a bit further explanation from Prof?
Sorry?
About the question.
Sorry, what is the question? What is the question?
No,
what is the question?
Who will be the owner of the database, and will it be enacted by law? Like the owner of this database is this, and there will be a law associated with it, or?
Yeah, the Ministry of Agriculture will own the database. Will host in a way. Will own, maybe may not be a good word. Will host in the data center of the Ministry of Agriculture, but different people, different researchers can share their data or can upload their data there, but the policy and the guideline as will be approved next time, will have its own policy laws. We have embargo period and so on. So it's very difficult to say that the owner is Ministry of Agriculture, but we will manage, the Ministry of Agriculture will manage, but properly to the policy, because the researchers may have a space there, but their data may not be shared. Yeah. There will be embargo period and so on. So we have a guideline. The guideline will be again approved with the policy. That's how we will work with the database. Is it clear, Professor Muthuku?
Yeah, I think it's okay. We can discuss later if there is any. Chipo, once more. Sorry, Beza from the Arena, I think she asked it twice, so we have to tackle. She's saying, does the system, the one Tseggai presented, have APIs for access? Tseggai may comment on that.
API means application. What is the API mean? I don't have APIs.
Maybe to further explain this one, just
what is API?
Yeah, usually like. Okay, thank you for your presentation, Tseggai. In your presentation, you explained that based on the policy, the system will have different logins for different users, right?
Yes.
So, like when I say API, like for other systems to utilize this data, like for different applications to talk to each other, like that is have like based on permission, based on the policies for other systems to directly access it through the API to get the data, like application level.
I don't know if I understand your question. The database has XML output, CSV output. That's where we are now. So you can use the raw data. What I mean is you can fetch or you can download raw data from the system. We have the option that allows us to take the raw data, not only the reports. For some researchers, we can provide access so the researchers can take some raw data, for example, raw data in essence, the result of the laboratory. Before it goes to the output, they may need that result only, so they can download that data. We have these options, these features in the system.
Okay, thank you.
Is it clear?
Yes, thank you.
Yeah.
Great. Oh, thank you very much, Mr. Tseggai. I think that was a very great session, and thank you all of you for the level of interaction. You can always email Mr. Tseggai with any more questions that you might have.